In this tutorial, I'm going to be talking about the different keywords and showing you how to make a phrase into an expression. So we're going to take words and we're going to put them into a number sentence. So first, I want to show you, this is your textbook. It's a digital version of your textbook, but on page 120, see right here, chapter 3, 120, you will see at the top a whole bunch of keywords and phrases that will help you understand if you are supposed to add, subtract, multiply, or divide. I suggest you look that over and memorize those different keywords and phrases. So now I'm going to show you some examples. So in class we did some, and these are slightly different. Perhaps we will do them on Monday. So first, it says the sum of 12 and a number t, and we want to make sure we're actually telling the story that the words are saying. So sum means to add. See why it's important to know what these words mean. So 12 and a number. So first it starts with 12, and then I'm adding that number. I'm adding t. We don't know what the number is. We just know that it's a variable. It could be anything. Maybe it stands for time. Maybe it's a total of food. We don't know. So we just say 12 plus t. Now I go to the next one, a number h times 8. A lot of you might think, okay, I'm going to put h and then 8. Well, just for organization's sake, mathematicians do not do that. If there is going to be a number times a variable, we put the number first, the quantity first, and then the variable second. So it would be 8h. You could also write it h times 8, which is fine, or 8 times h, but the neatest, most organized, simplistic form, this would be the best to go with. Now if I go down to the difference, if you're finding a difference between something, you're going to be subtracting. So if I say, okay, so I'm 5'8", and my friend is 5'6", what's the difference between us? Well, 2 inches, okay? You had to subtract. So think difference between something is subtraction. So the difference of 7 and a number. So the difference of 7 and a number. Now, decreased also should make you think subtraction because we're getting smaller, we're decreasing. So if I have 11 decreased by a number w, that would tell me, so the by a number would tell me that I started with 11 and then I was decreased by whatever that w is. And like I said before, if you need to, just for your sake, before you enter your answer, if you need to pretend that this is a number, do so. So let's say 11 decreased by 2. Well, you know you would write 11 minus 2. But once you figure that out, make sure that you rewrite with the variable, okay? Because you will get it wrong if you just throw in any number you want. It's just sometimes putting a number in can really help us understand what the sentence is actually asking us. So now if I go to the next one, a number n divided by 2. So I know that n is going to be first because it is the one being divided, and it's being divided by this 2. And then the next one, twice a number p. Twice, you know, is 2 times more something, right? So twice the number p would be 2p. Twice as big. So now I want to go down to this one. So now if we look at something, I know words, scary, but it's not. So let's say you plant a tree that's 10 inches tall, okay? So this lovely tree, and you know how I like to draw pictures. You should all draw pictures too because it really helps understand. So this guy is 10 inches, okay? Each year its height is increased by 15 inches. Holy smokes. Wow. So it is adding 15 inches every year. That is a lot of inches. So you make a table that shows the height of a tree in 4 years. So if I was to make a table, my constant is 10. It's always going to be 10 because that's where we start. Not always going to be 10 because we're going to be increasing it. However, that is our baseline. That is where we start. Just like the one with the piggy bank with $45, we started with 45 and grew from there. Here we're starting with 10 and we're growing from there. Okay, so that's my constant. My equation is going to look like this. I'm starting with my 10 inches, and then every year I'm going to be 15 inches bigger, but I'm going to multiply that by how many years there are. So if I did it with 1 year, so this is my equation, and then I'm going to put my different years here. So let's say I have 1 year, and then what is it in 2 years? What is it in 3 years? And then what is it in 4 years? So then I want to plug in the year is going to be y. Okay, so this is y. These are my variables, 1, 2, 3, and 4. And I'm going to plug that into my equation each time. So if my first one is 10 plus 15 times 1, PEMDAS says 15 times 1 is 15 plus 10. So I know that in 1 year, the tree is going to be 25 inches tall. So now I'm going to go to 2 years. So I take my equation and I put in 2 years. PEMDAS says I do this first. So now I have 10 plus 30. 30 plus 10 is 40. So it'll be 40 inches in 2 years. In 3 years, I plug it in again. So I have 10 plus 15 times 3. So now I have 10 plus 45. So I'll have 55 inches in 3 years. And then in 4 years, do that again. So PEMDAS says do this first. 15 times 4 is 60. So in 4 years, it will be 70 inches. Now this one says, well, hey, can you jump all the way to 9? Sure can. All I have to do is put it in for y. Oh, I see. It said t to use t, but I used y. It's okay. So I'm going to plug in 9. So I can also just extend all the way to 9 years by plugging that into my equation, the same equation. So 10 plus 15 times 9. Oops. Sorry. So in that many years, it would be 145 inches tall. Woo. So it's pretty cool. This kind of looks like chaos right here, but algebra is so interesting because you can, those variables, once you can put those numbers in place of all those words, really the sky's the limit of what you could figure out. Pretty awesome.